Hi, my name is Nur Sabrina binti Azzi, and today I'm gonna talk about my individual feature implementation for the computer organization and architecture course using MIPS assembly language. My selected features is display code at even or odd index positions. This feature displays security codes stored in an array based on whether their index position is even or odd. In MIPS, array indexing starts from 0, therefore even index positions are 0, 2, 4, 6, and 8, while odd index positions are 1, 3, 5, 7, and 9. The objective of this feature are to practice array traversal using loops, to apply branching instruction in MIPS assembly, to distinguish between even and odd index positions, and to control output display based on logical conditions. This feature focuses on understanding how data is processed at the hardware and instruction level, which is a core concept in computer organization and architecture. First, the security codes are stored in an integer array in the data segment. An index counter is initialized starting from 0. A loop is used to traverse the array until the last element is reached. For each iteration, the index value is checked to determine whether it is even or odd using a modulo operation. If the index matches the selected conditions, either even or odd, the corresponding code is displayed. Otherwise, the program skips that value and continues looping. How input is processed and stored? The input values are stored sequentially in memory inside the data segment. Each integer occupies 4 bytes, and the base address of the array is loaded into a register. The address is incremented by 4 bytes for each loop iteration to access the next array element. This demonstrates how memory addressing and array traversal work in MIPS assembly. In the text segment, instructions are executed sequentially starting from the main level. A loop is created using a branch instructions that checks whether the index has reached the end of the array. If the condition is not met, the program jumps back to the loop level. Branch instructions such as BEQ and PNE are used to control whether a code is displayed or skipped. Data segment. The data segment stores the integer array containing the security codes. It also contains a string message used for output display. These values remain unchanged during execution, while the text segment instruction manipulate and access them using memory address. Looping is implemented using a combination of increment instructions and branch instructions. Branching is used to compare the modulo result with 0 to determine even or odd index positions. For example, if the index is even, the program displays the code. If the index is odd, the program branches to skip the output. I'll explain about what happened inside the register during execution. The register S0 stores the base address of the array. This register is used to keep track of the current array element. The register T0 acts as the index counter, starting from 0 and increasing by 1 for each loop iteration. The register T2 stores the result of the modulo operation used to check whether the index is even or odd. The register A0 is used to pass data to the system call for output display. The program counter automatically moves to the next instruction in the text segment unless a branch instruction changes the flow. To display codes at odd index positions, only one instruction needs to be modified. The instruction BNE T20 skip is changed to BEQ T20 skip. This small change demonstrates how branching conditions can alter program behavior efficiently. This output shows the security codes displayed based on even index positions, When the condition is changed, the output correctly displays codes at odd index positions. This confirms that the features works correctly as intended. The LW instruction is used to load array elements from memory. The ND instruction checks whether the index is even or odd. BEQ and BNE control the program flow using branching. ADDE increments the index and memory address. Syscall handles input and output operations. In conclusion, this feature demonstrates how array indexes can be used to filter and display selected data elements. It reinforces the understanding of loops, branching, registers, and memory addressing in MIPS assembly. This implementation successfully meets the objectives of the Computer Organization and Architecture course.